Okay, should be recording. Or it might be worth it to share out to other people. So my name's Sean. I teach at ASU and I do tech consulting. So I work for a handful of companies, about four on at any given time. And I do various things from all the way from like consulting on like process for teams to writing code and solving specific problems. So, I've been a developer for 12, more than 12 years now. Kind of got started with building basic websites. And then, obviously over the last 12 years, the technology and industry has changed a lot. So, a lot of what I do has changed a lot, but it's been exciting. It's been awesome to see it evolve and, really happy with where things are at today. Things used to be a lot harder. But we also did a lot less, things that you're expected to do now are a lot more advanced than we were doing in the early 2000s. So it's pretty cool. Some of my background, I founded two companies. Both were, well, Orange Slice was kind of a failure. Logic was a little bit of more of a success. I sold that to jobbing.com, where I worked at as a lead developer for a couple of years. Worked at Tuft & Needle, was heading up their development team, and I was also a product manager at GoDaddy. So kind of had a wide range of things, from a bigger company like GoDaddy to when I started at Tuft & Needle, it was 10 people. So I was employee number 10. So totally different, but it's really exciting to, kind of be on the ground floor and building out systems that I'm sure a lot are still in use today, even though they're, I think, several hundred people. So I was sharing some stuff with memes with Natalie today, because she's like, I just feel like I'm Googling stuff all the time. I'm like, yeah, that's literally what we all do all the time. It doesn't change, so it's okay. All right, so if we were to start with some basics, we can blow through this or we can take it slow. You just kind of keep me on track. But if we will go through data types, variables, functions, and feel free to ask questions too as we're going through it, because some of it you might know, I don't know. So I'm happy to dive into anything you need me to. Okay, so I've kind of walked through data types, kind of like the lowest level as a really good first place to start. So in JavaScript and in any programming language, really, there's all these different data types that you can work with. Things like strings, things like numbers, and so forth. And so these are kind of like the basics of like how you work with stuff. Ultimately, a programming language manipulates data, and the code that you write, is used to transform, translate, and transfer data to all sorts of different things. So ultimately, it comes down to data and then functionality that supports that data. And so that's where we get all these different data types, like strings and numbers. Strings, which you probably know by now, is a form of a data type that is just text. And so my name is Sean Coleman is a string. And then we can look at numbers, so obviously that's integers, whole numbers, we can do decimals, and so forth. Negatives, positives, pretty straightforward in JavaScript. Some programming languages actually like differentiate the different number types. It's actually pretty unique for JavaScript to just have like plain number. Most of the time you have ints, and then you have other different decimal types. So you may have like a decimal type. So what's interesting in JavaScript just kind of makes it simple, but that's actually kind of rare. Most languages don't do that. So what are some other data types we got? Got arrays. So arrays, I like to think of just like collections. So they're collections of other data types, a list or, a set. In the generic sense, it's just a collection of stuff. So this could be an array of strings, and you could say like Sean, Natalie, new friends. So this is an array. So it's, the syntax for basically grouping together multiple other different data types. In JavaScript, arrays can have all sorts of different data types in it. So it could be a collection, it could be numbers in here, integers, and so forth. It could even be other arrays. So we can have an array that's like nested array. So that's cool too. You know, again, there's certain use cases for that. But what's great is, you know, if you think of these as like the building blocks, you can start to see kind of how everything is piecing together already. And then we have objects. So objects are where things get a little more complex. Objects are basically collections of keys and values. And so arrays are just the values. You know, there's no key associated with it really, not explicitly at least. You got one value, you got another value, but ultimately it's just like a bucket of values. The only thing explicit about an array is they are ordered. And so this is in position 0, then you have the next one at position 1, position 2, and so forth. And so that's called the index. Index refers to the position of the array element. With objects, we have both explicit keys and explicit values. So what we can do is say, let's say we have an object that represents a person. We can have their name. Usually we write it just like this. So we have the key and the value. We can have age, and then this is going to be a number, and so forth. So objects can be a collection of these keys and values, but the values themselves could also be any other sort of data type. So we can have an array as a value. So let's say I have a property or a key called shoes, then I can have an array of the different types of shoes I got. I got running shoes, I got hiking boots, and so forth. So what's great about objects is you can have a collection of all these different types of data that come together. All right, so those are kind of like, I would say, like some of the basic data types. Is there anything about data types we want to dive into? Any questions? Okay, cool. All right, so those are like the real basics of just data types. Then what's great about JavaScript is that, you know, we define this data here, you know, inline like this, but it's hard to kind of like pass that data along and run it through functions and do stuff with it unless we assign it to a variable. And so then we get into variables. So what's great about variables is we can just kind of basically assign like a pointer or a reference to the underlying data of something. So up here we got like a string, my name is Sean Coleman. So we can assign that to a variable called, let's call it introduction. So now we have the introduction. And if we want to use that variable, it's just a matter of referencing the name of that variable. So like introduction. So this const here is saying that, hey, the next word after this is going to be a variable, and it's specifically going to be a variable that can't change. It's constant. It means it's defined once and you got to use it, you know, you can never reset it. The alternative is if we want to do something that can change. So one way to do that is with let. And so let is saying like, hey, the next thing is going to be a variable, but it's going to be something that can change. So you can reassign it. You can change what the data is. So let's call this introduction 2, and we can say my name is Sean. So these are two different ways of defining variables. So we have introduction, we have introduction 2. They're both variables, but introduction, if we were to try and reassign that, it would give an error. So I'm going to run some of this code now. This is not valid code up here, so I'm going to comment that out. But I'm going to run some of this code over here. So we'll just run this and we get, hi, my name is Sean Coleman. So this is logging out the first variable. Let's try running with the second variable. All right, so then you see we get the two different lines that logged out here. So two different variables, pretty straightforward. However, let's try and reassign or change one of these variables. So I'm going to try and change the first variable introduction. We'll see what it does. So we'll do introduction equals to, you know, my name is John. All right, so since we don't prefix this with const or let, you know, and it's already defined, what we're doing is saying, hey, the variable's already been declared once. And so we're just going to actually redefine it with new data. So in this case, it's just a new string. So I'm going to try to run this. I honestly don't know what it's going to do, but we can't really do this because it's redefining a const. So we'll see. Hey, we got an error. Assignment to constant variable. All right. So it's checking for us and it's saying, hey, you just can't do that. Does anybody know why you may want to use const over let? Like it, you know, they kind of do the same thing. It's just const, you can just not reassign it. Any ideas? So like one good case is like, let's say that you truly do have something, you're like, there is no reason for this to get redefined. You know, maybe it's like the name of the application, or it's something where it's like, this is fixed and set in stone. I just don't want it to get accidentally redefined. So that's one good use case for const. It's something that we use a lot. In fact, most of the time, if you see lets, sometimes there's a way to do it where you don't redefine things. So we use const a lot, we use let a lot less. And so most of the reason is that when you define something, if you leave something open to get redefined down the road, that could be a source of bugs. So it's not that there's plenty of good use cases to kind of like redefine variables and so forth. But it's one of those things that provides a little safety, you know, especially for future developers that come into your program and now they're working on things and they're redefining things. You know, if they don't get these error messages, they may kind of screw something up. So, all right, so then we can try redefining instruction 2. Let's change this to instruction 2. We can run this down here. All right, so then it redefines it and prints it out. So that's like the basics of variables. Now you can do a lot more than just strings, of course. We can do arrays. So let's copy the array over here. Let's just call this const my array. I'm going to print this out. Let's see what we get. All right, so just kind of printed out the same stuff that's in that array. All right. Should we dive into some array methods? Would that be good next, or should we go into functions? What would be best for next step?
I do have problems with, well, I guess it'll be functions. Because I have problems like with the for loop and stuff like that. So yeah,
Awesome.
I think for functions.
Okay, awesome. We can definitely dive in there. Okay, so we did the data types, you know, but that's like kind of half of the programming language. The other half is like the functionality, the functions. So with that, I'm just going to kind of start a new file here. All right, so functions. So functions are basically think of them as variables of functionality versus data. So I think anything in a programming language could basically be divided into those two things. Is it data or is it functionality? Like in a real loose sense. So functions are a way to define functionality in something that can be reused. And so just like variables, we can reuse this anywhere in our program. We can do the same with functions. So let's have a new function and let's just call it my new function. Actually, let's call it, say, hi. All right. So this is going to be a pretty basic function. It's not going to take any parameters. we'll dive into that next. But all this is going to do is print out to the console, hi. All right, so if we run this, we don't get anything. Even though we have console.log here, it actually doesn't really do anything. We define a function, but we never call it. And so therefore, if we run this file, it's going to be like, all right, you defined a function. I know what the function is supposed to do, but you never called it. You never ran the function, so it's not really going to do anything. So to run the function, all we do is call it like this, and then we add the parentheses. So if we run this now we get hi. So it ran the function. So first we define the function, and then we run it. Pretty straightforward so far. Awesome. All right. So functions can also take parameters and they can do stuff with that data. So one thing that's common is, making a function a little flexible. You want to give it some data to do stuff. So we can give this function some data, and we can call this my name. So this takes in a parameter called my name, and we're going to create an introduction for this. So I'm going to say, hi, I'm, and we're going to use string concatenation to create the new string. So this says, hi, I'm so-and-so. So what this does is it takes string here and it joins it with this variable, which is also going to be a string. This plus sign just means that things are going to be joined. So if you're adding or using the plus operator with two strings, it's going to join the strings. Obviously, if you use the plus operator with numbers, it's going to add them. So same thing, though other languages don't usually use the same thing. So, it's kind of weird that JavaScript actually uses plus for both addition and joining strings, but every language is a little different. So we're going to run this, and I'm going to pass in my parameter Sean. All right, so then we get the output here. Hi, I'm Sean. So this is a way to basically be able to pass in data and make these functions a little more flexible. So what's great is we can extend this and reuse the functionality, but with different data. So now it's making it a little more flexible. Sorry, I don't know everyone's names, but I'll just type some stuff from today. So now if we run this, we get 4 lines with the same thing, just different data. So now we're starting to see like some of the power of like programming languages is we can quickly do things and kind of like encapsulate the functionality, but reuse it in a lot of different contexts, which I think is really exciting. That's like, as soon as you start to do some stuff where like, wow, I did all this functionality, but only with a couple lines of code, that's really cool. So so that's like the basics of a function. Let's see. I think the other thing was callbacks. I think that's something that everyone's been kind of looking at. Would it be helpful if I dive into callbacks? All right. All right. So a callback is really just a function that you pass into another function. It's called callbacks usually because you're calling back to that function. So usually you run the function and then you run the callback after. And so that's why it's usually called a callback. But in the very basic part of it, it's just a function that you pass into another function. So we're going to define another function here called say bye. Let's actually move it down here. All right, so we got these two functions here. I'm going to modify the first function to take in this callback. All right, so we got this parameter called callback. The great thing, I know we oftentimes call these callbacks, but they could be called anything. It could be called run this function callback. You know, it really doesn't matter. Callback is not like a special word or anything in JavaScript. It just happens to be a convention that we often call it. So we pass in this function, we're going to do something with it. So I'm going to run it just at the end of this function. All right, so let me run this and we'll see what happens. All right, so we got an error. Callback is not a function. So why? What does that mean? Well, we look here that we see we're calling the function, we're passing in the first parameter, but we're not passing in a second parameter. So what that means is the second parameter, if we don't pass it in and we don't like tell it anything, it automatically comes in as undefined. And so we can actually see that. If I were to like debug this, this is what I would do. I'd be like, okay, why is it not a function? Why is it telling me that? You know, so I'll comment this out and I'll just log out what callback is. So I'll run this. Great. All right, so it's undefined. So that's like the default behavior of JavaScript. Again, what's really somewhat unique about JavaScript is you can call a function, even though this function is defined with 2 parameters, you can actually just call it with 1. And it just kind of is like, well, all right, well, I guess I'll just like pass an undefined automatically. Literally what JavaScript is doing. So it's kind of interesting, but it also makes it kind of flexible. So let's put callback back. And let's pass in our new callback function here. And I'm just going to pass into every one of these instances. All right, so let's run this. All right, cool. So we got the output here. For each of the 4 times we call the function, it then calls the callback afterwards. So really, like in the simplest form, it's basically like instead of data as a parameter, it's another piece of functionality. But what's great is it makes it really flexible. So we can maybe add different types of salutations here. So let's define another function. Sorry, I'm not being very creative today with my function names and stuff, but let's just add a different one. All right, so Sean, say bye. Natalie, I'm gonna say see you again, and everyone else gets bye. So now it's pretty cool because we can run this and you see now we get a little more flexibility. So we get a different text that prints out for Natalie, whereas everyone else is sold by everyone. So that's what kind of makes the callbacks powerful is we can actually pass in like even more functionality for it to call. All right, any questions on callbacks? Should I move on or? Cool. All right. So we did callbacks, we did functions, did variables. I think loops is a big one, right? Okay, cool. Let's do loops. Yeah. Okay, so let's dive into some of the scopes and loops and all that stuff. Okay. Has anybody run into an infinite loop yet while they're developing? Kind of crash their computer, fans burning up and stuff. That's kind of fun. All right. So again, I think what's really cool about programming is that in like very little syntax or code, you can actually have something do a lot very quickly. And so one way to do that is with loops. Now there's a lot of different types of loops that you can do. The simplest one, or not the simplest, but the, I would say the most, I don't know, primitive is probably a for loop. Have you guys worked with while loops, or I know you've done for each, maybe not while loops. Okay, so we'll just do for loops, since that is kind of like the kind of root of all the loops. So for loops, you know, I remember learning for loops, and they're one of the most difficult things to learn because even they're deceptively complicated. They look really simple, you know, it's like one line, but there's like a lot going on. And so they're pretty deceptive. So there's three parts to a for loop inside the parentheses here. So the first part is where you set the initial index or the count. Oftentimes we call it I or index. You can call it anything you want though. That's the great thing. So we can call this, let's call this index. So that's the first part. The second part is the comparator. So we want to say, okay, we're going to start at 0 and we're going to run this so many times. And so we're going to say, keep running this loop until or while index is less than 10. All right. And then the last part is, what do we do to increment index, or like, what do we do with index? So we can do index is equal to index plus 1. So that is the kind of like basic structure of a for loop. So the reason I say it's kind of deceptively complex is that there's actually 3 lines of code in here. Even though it's technically on one line, remember the semicolon usually indicates like another line of code. So in this for loop, we actually have like 3 complex lines of code. So that's why it's pretty complex. Trust me, I sometimes don't even remember the order of these. You know, is it like, okay, is this one here, or is it the comparator is at the end? This happens to everyone, so it's okay to, you know, feel like if you constantly need to Google, hey, what's the syntax again for a for loop? Happens all the time. So we're gonna try and run this, see if I wrote it right, and see what we get. All right, it didn't work. Index is not defined. Okay, well, it's probably because we didn't prefix it with a const or a let. So we'll do let. Now the reason we need to do let instead of const is because const isn't going to work, because we're going to actually reset index on every iteration of the loop. So I'll prefix it with let, and then we'll try running this again. All right, so we get 10 iterations of the loop. Pretty cool. Now what's really cool is, you know, we can like increment this to anything. I mean, let's see what it does when, what is that, 1 million? I don't know how long that's gonna take, and my computer may crash here soon, but it's running away and it's doing it. I think that's 1 million. Yeah, it's 1 million. And it's done. So that's really cool. It literally just printed out, well, actually 2 million lines here, right in the console. I'm literally scrolling through 2 million lines. I mean, it just cuts it off. It's too many. I just did that in a few seconds. So pretty powerful stuff. I don't know. It's exciting. So that's like the very, I think like the structure of a loop. Now, there's different, like each one of these really lines of code is, can be, you know, presented in different ways. So like with index, it's very common that we do index plus, well, so oftentimes you see index plus plus. So that is just the shortcut for index is equal to index plus 1, which is the same as index plus equals to 1, which is the same as index plus plus. So in development, we call this syntactical sugar, meaning it's literally the same functionality, you get the same result. It's just, this is a little nicer. It's a little neater, a little sweeter. So we call it syntactical sugar. And so we can do different things. We can actually do index, let's start at 1 million. Let's do while it's greater than 0. And then let's do minus minus. So obviously minus minus is just the opposite of plus plus, where it's subtracting 1 with each iteration. So I'm going to just add in here console.log. I'm going to log out the index. So we'll see what happens here. I'm going to comment this out so we just see the numbers. Run this. There we go. So we printed out, I guess it was only 100,000. That's pretty weak. Let's do 10 million. So it's printing out 10 million numbers, subtracting 1 each time. and it's going to take a little bit of time, it looks like. But it's doing it. It's doing it literally as fast as this computer can do. And if you could hear the fans right now, they're kind of, computer's about to take off. But that's powerful, or the power of loops. So I think it's pretty cool. What else can I dive into with loops? Any parts of it questions I can answer?
Well, I actually have problems like, it's hard for me to explain certain things with JavaScript, but like if you had an array with objects in it, and you're looking for certain keys, or I'm sorry, I don't know if I'm using the right words, but how would you like console log it to find certain keys in each object? I don't know if I'm saying it right.
Yeah, I think I know what you're saying. So let's start with an array of objects. Let's at least get that far. I'm going to keep it real simple just so I don't have to type a bunch of stuff. So age. So I'm just creating an array of objects here, nothing too advanced.
So like if you wanted to like only console.log the ages that's over 20, something like that.
All right, that is perfect. Let's do this. So we got people. All right, so we got our people array, which is an array of objects, and we're going to log out only the people who are over 20. So there's different ways of doing this. We'll use a for loop though, and then we can do a for each loop, and then we can do a filter. I think you guys have done filter. So I'll show you all the different ways we can do this. So the first thing we want to do is loop through every item of this array. I'm going to keep this right here. I'm going to comment it out. So we'll start with a new for loop. So best thing to do is, well, let's actually call this I. It's more common, so we'll just stick with I. So we're going to start at 0. Arrays start at 0, so may as well start I at 0. We're going to do I is less than people.length. So length is a property on people, the array, that just tells us how many items there are. So I think that probably have covered indexes, but the index of each object, starts at 0. So the index here is 0. The index here is 1, and so forth. So the length of this array is 3. Even though it's 0, 1, 2, the length, of course, is 3. There's 3 items, so that doesn't change. So that's why we can do less than instead of less than equal. I know at least for me, when I was learning this, I remember having trouble, like, is it less than or equal to? Is it less than? If you kind of just think through, like, okay, it's going to start at 0, 0, 1, 2, 2 is less than 3. The next one would be 3, but 3 is not less than 3. So it's going to stop there. And that's what we want. Because if you try to access the index of 3, it's going to give an error because there's not an index of 3. So do that and I++. All right, so we got our loop there. Hey, our 10 million finished. That's cool. Finally. Okay, so to access an element of this array, we use the square bracket notation. So we'll do people of I. So this is just like if we wanted to do like people of 0. So I'll actually just console.log people of 0, and we can, let's just see what this does. So comment this out real quick. So we run this. Okay, so we get the first person. Great, pretty straightforward. All right, so I'm gonna start, before we start doing like our filter and stuff, I'm just gonna log out all the people in the array. We'll just like start there. So there's this like saying in development which is like, make it work, make it beautiful, make it fast. And so, you know, I always like try and like constantly just like keep the program working as I add more complexity into it. If I write out this big for loop that has an if statement and checks the age and gets that property, that's a lot of functionality to write. And if you run it, unless you wrote the code perfect, which I know I never do, it's going to give an error and you're going to be like, okay, where did I go wrong? So I always like to kind of like keep running things very iteratively, like add a line, run it again, add a line, run it again. And then if something breaks, you're like, okay, well, I know what broke it is the last line I added. So that helps. And then after that, then you go through the refactoring process, you clean up the code, make it look better. And then optionally, you can sometimes optimize and make it faster. If our loop of 100 million was too slow, we can figure out ways to make it faster. So anyway, sorry, that was a lot of tangent, but I'm gonna run this and we're gonna see what we get. All right, cool. Exactly what I expected. Print out the 3 people in the array. Okay, so the next thing we want to do is try and filter these to just the people with an age of greater than 20. So to do that, I know I need to somehow like get at the age of the person. So I think what I'll do first is just set a variable to the person, because then now I got like a person to do stuff with. So I can, you know, do .age, I can, you know, put that in an if statement and so forth. So I think I'll start there. And again, I'm just gonna log it out. Should do exactly the same thing, but I just wanna make sure that this new format works. All right, great, same thing. That's what we expected. So I know I need an if statement. So I need to check each of these and see if they're more than 20 or not. So I'm going to do if person.age is greater than 20. Then I'm going to print out that person. All right. There we go. So we got the 2 people that are older than 20 printing out. So that's, I think, probably the most basic way of doing this. Now, one way is, you know, now that I'm looking through this, I'm like, okay, we set the index of people to a person variable, and then we access that. You know, it actually is possible to just access it directly like this. And we don't even need this. Not saying it's better, but it is possible. So this kind of like shows how like things can be chained together. And so because this variable got set to what this is, it literally is as if you were like to copy and paste this and just replace it. It's a reference to exactly that. So different ways of doing things. So let's add some complexity to this. Let's say that the requirements changed and we're like, okay, but I actually want you to create a new array of just the people who are older than 20. Okay, how can we do that? Okay, well, we definitely need a new array. So I'm just gonna say old people. It's gonna be a new array. All right, so what we can do is instead of logging out the person, we can add to this array that person. So we'll use the push method. And so again, the push, just like length, is something that's attached to the array. It's already built into the array. So we can do .push, we add the person, if they're over the age of 20, and then we'll see what we get. Let's run it. Okay, nothing printed out. I don't know. But that's actually expected because we didn't log anything out. So why don't we log out the array at the end? All right, run this, and we get the 2 items, and they're in a new array. So that's one way to go about kind of like, okay, let's get all the people, put them in an array, so forth. And then, yeah. Should we dive into this more with the loops, or we can go to different array methods?
I'm all good on the loops. Thank you.
Okay, cool.
That was
good to hear.
Informative.
Awesome.
John, do you mind like touching on scope of like, awesome, I don't really know if I'm saying this correctly, but like a lot of times I struggle like with the for loop, like where to define the variable like for something. So it's like, oh, I might have defined it like before my for loop. Does that kind of make sense?
Yeah. So variable scope, I mean, it's an important thing because it defines where the variable is accessible. So if you think of like a program, like right now we got one big file, we have 3 functions, we got a couple variables. Right now, for the most part, like just about everything here is what we call global scope. It's the top level. It's not, embedded in a function or anything. So most everything here has global scope. Something that doesn't have global scope is something that's usually inside a function or a loop or a conditional. When you declare, and declaring is where you have to have the prefix of const or let. When you declare a variable inside of a scope, such as a function or a loop, that variable is only known or accessible from within that function or that scope. So if we were to like log out person, even though person is defined above console.log, it's within the loop. So it's outside the scope of where console.log is being called. It's contained to the scope of this for loop. So if we were to run this, probably get an error. Yeah, person is not defined. Well, it is defined, it's just not defined with the right scope. So one way, and again, this is, we're gonna try an example, but like, let's say we defined a person, let's do null. Let's say we defined a person like outside the loop. So now they're at the same scope level. And so of course we don't need const anymore because we already defined it. So we define the variable outside, and instead of defining it inside the loop, we're just gonna redefine that variable, or redeclare, sorry, not redeclare, we're gonna reset that variable to each person of this array. And so it's gonna set it 3 times, and then we're gonna log out a person outside of the loop. So we can try running this. All right, so that worked. And it logged out the last person, Harold. And that's because that was the last time it got set. So because we defined it at the same scope or the same level of console.log, we had access to it. So that's one way to look at scoping. Trying to think of a better way to kind of explain that, or a better example. I think I know one thing I was seeing is it helps a lot to make sure spacing is right. So like even if we add in a bunch of spaces like this is still totally valid code. This will work just fine. Oh, sorry, I forgot I have a plugin that automatically reformats my code when I make it ugly. So that's what that was doing. But this right here, this will run. But the problem is like the spacing's all off. So it's really hard to like tell visually like what's the scope of person. Like I guess it's inside the loop, but everything's kind of off. So one thing I always say is like get your spacing right, and that helps at least visually kind of see like literally like it's either inside, it's indented in, or it's kind of outside something. So I don't know, that's just a tip I figured I'd share. It helps a lot. And then yeah, if you want to kind of play around, there's a tool called Prettier, which is what I got. So I'm going to save this file right now, and you're going to see it instantly formats all the code. Boom, fixed it all up. So if you want to check that out, called Prettier, and you can set it up so it works with VS Code and can make things a little nicer. Does that help with scope? Or I'm trying to think of a better example. Or if there's any specific questions on that or something that got someone stumped. Okay. All right, should we do array methods? I think advanced array methods. Reduce, I know we were talking about earlier. Is that helpful? Or should we do something else? I know there's classes and prototypes. Well, I'll do the, I think there's like 3 array methods. I can cover those real quick.
I got a question on a particular question.
Yeah, yeah, let's do it. Of course.
So like, there was a sprint assignment with array methods and stuff in it, and on one of the stretch goals, it had asked if we put in the parameters of the data, like of all the objects, and team initials to get how many times that team had won, and so and it says hint, use reduce, and I solved it, but like I couldn't figure out any place to use reduce, and I'm not the only person.
Yeah.
But, like what I did was I filtered it to get all of the winning games. I remapped it to get home team initials and away team initials whenever they would win, and then I filtered it again based on the team initials that I put in for the parameter, and logged it by like the links to get how many times and return it in a template literal. I don't know how to do that with reduce.
Yeah.
It's a really big question. Sorry.
No, that's great. I think that'd be a good exercise. Let's see if you can. So I know there's an array of objects, so maybe you can help me fill out what these objects look like. Yeah, I mean, it doesn't have to be the actual thing, just kind of like what the bare basics of it was.
I guess what you really need is like a home team goals, an away team goals, and a home team name, and an away team name, at least to deal with kind of what they want us to deal with.
Okay, so home team, away team, name, home team goals.
Yeah, because like every single object was like a game against 2 different.
Oh.
Yeah.
Okay, so each object represents a game.
Oh, and you'd actually need home team initials and away team initials as well. They have the name and the initials. The objects are huge, really. They got a bunch of crazy random things.
Okay, cool. Let's this will be a good one. Okay, so the goals is like, you know, like 3 versus 5, and so home team won or lost kind of thing, I'm assuming. Okay, I'm not really a sports guy, so I can't even think of a sports team name. So we're gonna use programming languages. Okay, so let's do a few of these at least. Probably the same teams, right? Although we could probably swap some of these.
No, they had a whole bunch of objects, a whole bunch of different teams, but if you just use 2, really, it would work the same way. You're just trying to put in the team initials, you know.
Got it. Okay, cool. Yeah, we can do this. Okay. Let's get some random number. right. Let's swap these. Trying to get a good mix. Okay, I think that's decent data. So we call this game or games. Yeah, it's probably reasonable. All right, so sorry, what is the goal? What do we want to do? We want to
put in, I guess, that data set and team initials and get how many times that team won.
Got it, based on the team initials that you pass in.
Yeah.
Okay, so we're gonna have a function get wins. I think that's probably reasonable. And it takes in initials?
Yeah, the data set and the initials, like 2 parameters, I guess. So it'd just be that array of objects.
And, team initials. All right. And then I'm just going to write out the call for calling this function. So it's going to take in the data set, which is games. And let's first do it with tr, I guess. Okay. Okay, cool. So we want to figure out how many times that team won. So I think I heard you say that you use filter, which is totally a valid way of doing it. Reduce would also work. They both work. And it's, you know, what's great is as you start to learn a bunch of tools, you realize, holy crap, these can like kind of substitute for each other. And so now you got like so many different ways of doing the same thing, which can sometimes make it more overwhelming than just having one way. So I think developers like go through a journey of like, you know, starting with like, okay, if I can just get one way to do this, that's a win. Like if I could just make it work, you know, I don't even know other ways of doing it. Then as you start to learn more things, it's like, okay, I could kind of see multiple ways of doing it. I don't know which way is best, but you know, at least I see different ways. And then finally you start to, you know, be more critical about like, oh, okay, here's, you know, reduce is better or so forth. So, let's do the filter approach. It probably won't look exactly like you did it, but I just want to kind of like go through that, and then we could look at refactoring it with console.log or with reduce. So first thing we're going to do is filter, and we're going to use arrow functions. I know we haven't talked about it here, but you'll see the arrow functions you're probably familiar with. So we're going to filter data set. I'm actually going to call this games. I think that's a little better than data set. Every array is a set of data, so it doesn't really add any value. So we're going to filter this to games that just have the team initials. Oh, but they could switch. So yeah, this is an interesting one. So first we have to, okay, so first we can filter it to, this is gonna be a big one. So I'm gonna wrap this. So if the game dot home team initials is equal to the team initials that I passed in, and so this means it's a home team. We're going to say is a win. Okay, so if it's a home team by those initials TR, so home, not home, home, not home, so forth. So it's a win if home team goals, game.home team goals is greater than away team goals. Okay. And then we're going to return is a win. Because remember the filter method needs to return true or false, and that will determine if it's included. Otherwise, we're going to assume it's an away team, in which case is a win is equal to game dot away team goals is greater than that home team. All right, so I think we got our function here. This is gonna, well, right now it's not gonna do anything because it doesn't return anything. But this is gonna get all the games that that team has won. And I think we wanna get the, ultimately we wanna get the count. Okay, so let's set this to winning games dot length. All right. Oops. Oh, yeah, new file. Let's call this team.js 4. I think that's right. So, sorry, what's our team? TR, yeah, win, not win, 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 win. Okay, yeah, so 4 wins. So yeah, so I'm guessing this, I mean, it probably doesn't look exactly like what you did, but I'm guessing that's the general approach of what you did.
Well, we had to do it. We had another factor, but I'm still just kind of trying to see a reduced way of doing it. We had to just take the finals game, the ones that were like the championship game. That was another thing that they had, and so I had
another filter.
First, and then I mapped it with to get the home team and the away team initials. And so then I filtered it again to get the actual thing because it made more sense to filter and to try to count it with reduced to me. But I can't even figure out how to count it with reduce because the way that I mapped it before. And I know that there's ways to use reduce with map, but I don't know.
Yeah, no, that's perfect. I want to get another filter in here because then I can talk about why a reduce is better. So I'm just going to do, I added the finals, so I'm going to do winning games, dot filter game where game is finals. And so final winning games. All right. Okay, so this is only going to do, so it filters it to the winning games and then it filters the winning games to the finals. And so now we got final winning games, which is only 3 now. Okay, so how do you do this with reduce? So I'm going to comment this out and we're going to start over with reduce. So we'll start games.reduce. Now, I think reduce is a good name for this function because it's always about reducing an array of data down to a single data point, usually a number. And so that's why it's called reduce. And we are going to, instead of filtering it and setting it back to an array and then calling .length, instead we are going to use reduce. So the general structure is the same, pass in a game. And in accumulator, or current value in this case. So we'll call this winning counts. Okay. Then I think, trying to think of how the first value is set. I don't even remember. This is where I'm gonna Google. Okay, it is after that. So this takes in 2 parameters. Reduce takes in 2 parameters. The first one is a function for determining what you want to add to that accumulator. And then the second parameter is that initial value. So we're going to start at 0. It's pretty common. So if the game dot actually, I'm just going to copy some of this code over because it's effectively the same. Okay, so if the home team initials is equal to the team initials up here, let me pull this out because I want to make it a little more clear. All right. Okay, so if it's a home team, then you do home team goals of that. Now, instead of returning true or false, we're actually just going to add team initials, or sorry, no, not team initials, winning count plus plus. And then if is a win, winning count plus plus. And we'll do the same thing here. And I won't do the finals thing. Well, we can add in finals. And the game dot finals. And the game dot finals. Okay, so this is how we can do it with reduce. I'll run this and see if it works. But this only requires one array method call, whereas the previous one required two filters. One filter, two filter. So what this does is, if we just walk through this, if it's a home team game for the team initials that you pass in, let's check if the home team goals is greater than the away goals, then it's a win. And we'll check if the game is a finals game, then we increment winning count, which starts at 0 because we define that as a parameter, and then we just increment it. Same thing's true if it's reversed. So let's run this and should get 3, I think. Oop. Home team initials is undefined. Why is that undefined? Uh, 463. Reduce game. Why is it undefined? Pressing get wins games. All right. All right. So this is good debugging. So I don't know why this isn't working. So I'm just gonna like inject in here a couple log statements. So it's saying game is undefined because it's trying to read home team initials of undefined, but I think game's defined because it's passed in here. So let's see what we get. All right. So I get 0 and then I get undefined. Oh, I see. So I printed out this as a second parameter, winning count, but that's actually the game. So I think I got these switched. So I'm going to switch those and then let's try running this again, see what we get. All right, so it's getting closer. So now we get what we expect there, but the other thing is I also realized we need to return these values. So we'll do that. Oh, get not a number. Let's log out the winning count here. Okay, so it starts on 0, goes to 0, then goes to undefined, then not a number, undefined, not a number. Got it. Okay, so you can see here that there's some places that it doesn't return. So I think what we'll do is we'll just get rid of the return statements here, and then we'll just always return at the end. Return winning count. All right, should run that. Great, so we got 0, 1, 1, 2, 2, 3. So that is the 5 iterations of going through games, and ultimately it returns a winning count. So I'm going to remove this console.log statement, and we get 3. Okay, so now that we know that it runs and works, I want to make sure I walk through this and see if there's any questions. So we start with reduce, and so basically it goes through the different conditionals. So the first one is, is it the home team? If so, then we figure out if it's a win. If it's a win and it's a finals game, then we increment winning count. So winning count starts at 0. And with each iteration, it's going to pass in winning count again. So first time it's 0. If it increments, it's going to be 1. If it doesn't increment, and there's several cases where it doesn't, then it's just going to return 0 here, and it's going to start with 0 again. So this is another way of doing the same problem, but instead of filters, you can use reduce. So hopefully that helped. I think the question is, why would you want to use reduce instead of filter? Or do you?
I have a question.
Yeah.
Do you need this like if statement in the beginning? Because you do the same code twice. Like it's if game dot home team initials is the team initials. Couldn't you? Does it matter? Because, I mean, you did else. I guess what I'm thinking is like you checked if it was team initials, and then you said, well, all other cases when it's not team initials still do the same code. So would we need that? Why would we need the conditional of if else in that? Do you know what I mean?
Yes. Oh, absolutely. Yeah. So it's very close, but you'll notice one key difference here. This is home team goals is greater than away team goals. This is away team goals
cool.
is,
yeah, thanks.
Yeah.
Yeah.
So it's, yeah, it looks identical. I mean, seriously, staring at this, I can barely see it, but so yeah, it's that one slight difference. But you bring a good point where it's like, hey, there's a lot of redundancy here. Could definitely use some refactoring.
What does refactoring mean?
Yeah, so refactoring is just a way of like changing code to clean it up without changing the underlying functionality. So we know what this function does, and we know it's working. We just want to make it cleaner, and so that process is usually called refactoring. Because you brought up a really good point. You didn't see it, and it's totally valid. And so a future developer coming into this could ask the same thing, like, hey, why is this needed? Like, delete. But now we know that actually would cause it to break, or at least not produce what we wanted. So there could be a better way of cleaning this up and refactoring.
Thanks.
Yeah, for sure. Okay, so we had two approaches to this. One used filter, and it used it twice, and one used reduce. But the reduce approach only had one reduce. You know, we didn't have two reduces like we did with filter. So does anybody have an idea of like why this might be better in some cases? So one reason is when you run filter, it runs through every element of the array twice. So it does it once here, and it does it once here. Now, with 5 items in an array, that's not a whole lot. The computer will do it in microseconds, and you're not going to notice. Let's say there were 100 million items in this array, and it took a solid 5 minutes to run through every one. There were 100 million games, and it took the computer literally minutes to run through every one. Well, if you run filter, and you run filter again, and after all that, you call .length, that is actually running through that array 3 times. So it's literally going to take 3 times as long. So if it took 5 minutes to run through one time, it's going to take 15 minutes for the function. Now, what's nice about reduce is it only runs through that array once. All the logic for counting up the winning games and conditionals, it's all within a single loop. So that's what's interesting about like these, what they call higher order functions like filter. You know, you can do all this with a loop, you know, for I = 0 and so forth. You can do that with a loop, and it's a lot more obvious what you're doing. Filter makes it really easy, but you can also kind of like get in situations where like, oh my gosh, we're running through this array, you know, like 10 times, and it's kind of unnecessary. Now, in most cases where you don't have like really big data sets, and I'm talking really big, 10,000, not a problem. 10 million, okay, now it's starting to get it's starting to get big, you know. And if we're talking Google size with billions and billions of data points, okay, now we got to think about like, we can't run through the array multiple times. Like it's just too long. So that's one way, but most of the time, you know, it's better to optimize for code clarity. So maybe this reduce function is I mean, it's a lot there. Maybe it's better to do multiple loops and it's a little clearer, you know. It's not going to scale as well, but it is cleaner. I think it's a little better that way. So hopefully that helps. But yeah, so there's no like right or wrong answer. There's better code for certain situations, but it totally depends on the context.
I think you do that with reduce. Yeah, that really helped me. I can do a lot more with it now. I feel like that helped just seeing it, other than just being told like how to get the averages or how to add something. Because I never like I thought about using conditionals, using math and stuff, but like, and the way you did it here is like, man, you could really say what you want to get. I don't know. It helped. Yeah.
Awesome. Good. Glad to hear. And I know you were asking earlier about like, do you really use reduce in the real world? Like, so I want to show you like, here's a library that's pretty used pretty frequently called Lodash. And this is, you've heard of it? Okay. Yeah, it's a utility library. I mean, there's a bunch, it's just a collection, like a toolbox of all these different functions that make things easier. And so I think you were saying like, do we use sum? Isn't there like just a dot sum? Yeah, in Lodash there is. So if I were gonna do a sum, this is what I would do. Just this. No reduce, no adding, no for loops, just that. But I know what it's doing in the background. It's doing a for loop. You know, you don't see it, but it is. So it makes it easier. You know, but at the end, it's, you know, it's still kind of doing the same thing. I think there's even a way to like see the source. Yeah, let's check out the source. Oh, here we go. Yeah. Okay, so that's a lot. Okay, so the entire source of the whole library, not helpful. But ultimately, like, you could create your own sum function. You know, function sum equals 2, and then you do a reduce and so forth. So reduce is a lot more flexible. Obviously, we can do all this, and sum's not really going to work on that. But you know, for sum, it's pretty like, you know, single purpose function. So what else can I show you guys?
That was really clear. Thanks so much for doing that.
Yeah, absolutely. Let me show you, I don't know, I think this stuff is interesting, and I think it may help kind of show like the inner workings of things. So like if we look at an array filter, we can actually look at the source code of what filter is actually doing. And so I think there's a way to see the source on here. Yeah, so this is actually the source code of what filter is. And this actually gets into prototypes. But what I think is really cool is when you call .filter, as we were doing over here, in the background, all it's doing is running these while loops. And a while loop is very similar to a for loop. It's just there's no starting point inside the loop. So it's very similar to a for loop, but it's just a different type of loop. But really, like, you can literally just copy and paste this code and replace it with filter and get the same result. So I think it's really cool. Like, if you're always like, what is the magic behind filter? It's literally this. So code on top of code. Tons and tons of layers, and sometimes you lose track of like where things actually are. But so yeah, so I think that's cool. But
what's that triple greater than sign? It says like variable length equals this dot length. Triple greater. Oh yeah.
All right, I'll show you a couple of examples. All right, so in JavaScript, you know, single equals is assignment, double equals is equality, and JavaScript is unique in that they have a triple equals. Sounds like you guys have mostly been using double equals.
No, I think they told us to use triple equals,
Okay.
until we really understood the distinction. I think it's the truthy falsy thing.
Yeah. So let me see if I can think of a good example. Okay, so let's do console.log. We'll do like my string is equal to my string. Okay, so we got double equals here. So let's run this. Okay, we got 3. Oh, wait, sorry. Wrong file. Okay, so we got true. Exactly what we expect. Yes, so triple equals is equality with type checking. So same value and same type. And so these are both strings and they both have the same value. So if we run this, it's gonna be true, just like we'd expect. I may need to look up an example for this.
Yeah.
I don't know the edge cases, but there's weird stuff.
I think that'll work. That's the one.
You got a good one?
About to do is going to be false, I'm guessing.
This would probably be false. It should be false. All right, that's false. However, if we do this, and I don't know if this is true or false, honestly, so we'll see. Hey, that's true. So I'm sorry, a string is equal to the number 1. I mean, maybe in some worlds, but they're pretty different. One's a string and one's a number. Yet JavaScript is like, you know what? Close enough. Double equals, close enough. We know what you're trying to do. So we're just going to say true. And this is, again, kind of unique to JavaScript. JavaScript has a lot of peculiarities about it. I've never seen triple equals in a different language. But basically, triple equals were added because people are getting bugs because, you know, this would evaluate to true. And that's not what people always want. You know, so this is what's considered a safer operator. It's a safer check. Because now, you know, of course, you're checking the type too. So like, if for whatever reason, and I'm trying to think of a good use case, but, you know, ultimately these things do not really equal each other. So it's not really good practice to assume these are both equal. So you could probably find a list of like edge cases like this. Trying to think of another one.
I think true, false. I think you can put like a true there.
Yeah, that's a good one. Oh, that's false.
But if you make the true into a 1, try putting like the 1 in, yeah.
Like that? That's true. What the heck? That doesn't make any sense. So yeah, it's really interesting. So, you know, someone came along and is like, this is not how we do programming. Okay, we don't have these fake equality operators.
So that's true for the triple greater than sign over there.
Yeah.
It also checks the
type. So in this case, that's going to be false. Just crazy. I don't know. So yeah, it's generally best practice to always just use triple equals. I don't really know of a good use case where you would actually intentionally use double equals. Even if you wanted to be a little looser with your check, you'd usually be explicit. So generally you'd basically do, you know, either, I don't know, let's say this was a variable, you know, my variable. Let's say you were like, well, it can either be 1 or true. You wouldn't just do double equals, you do triple equals, and then you do an or statement, and you do my variable is equal to 1. So even though this is like a lot longer, it's a lot more clear what's going on here. No, my variable's not defined. But yeah, so this is a lot better than being like, oh, well, let's use this cool new, you know, cool JavaScript double equals where it's, you know, either one of these. No, that's not not usually the best practice. So
we go over classes. I had this I kind of am curious how to like make an object, how to have a function that makes an object and adds it on to the bottom of an array of objects or something like that.
Yeah. Okay. Sorry. Can you repeat that?
Well, I mean, I don't know if you have something planned or if anybody else has a question, but if they don't, it'd be cool to review classes and inheritance and stuff like that, and it'd be interesting to know how to like within classes create objects and decide where it goes in arrays of objects or things like that. So like, let's say you have an array of objects.
Okay.
Maybe starting with like creating a function that generates a new object and adds it onto the end of the array.
Okay.
And then,
okay. So let's. So we'll just kind of reuse that, and you're saying maybe a function to add an object to this array.
yeah.
All right. Okay, that's probably fine. All right. Add object to array, and then we'll print out the games. Okay.
But what about like generating the object? So like, you know how you like, maybe you create a constructor function that says like new object?
All right. So let's do a class, right? Call this object factory. I apologize. I'm going to need to Google real quick the syntax of classes.
It's actually really cool to see you do all of this because just like watching you Google and debug is really useful.
Yeah, I didn't want to hold back. I didn't prepare for this at all. I was going to be like, at first I was like, I'm going to brush up on the things they're using and stuff. I was like, no, that's not how it is in the real world. You just kind of Google a lot and figure things out. So I was like, I'm going to make this pretty raw. And so I haven't used classes in a while. So so I'm just kind of following along.
That's awesome.
But I know I can something. Okay, so this will be a parameterless constructor. Probably doesn't even need to do anything, but this class. So do you think the array is going to be inside the class and then we're going to add objects to that array inside the class?
Oh, that's interesting.
Or whichever way, yeah.
Yeah, I was imagining it'd be, I mean, I didn't know that was possible. I'm interested in that too. I guess I was imagining it would be like an array, like a JSON object or something, and you have like a function that would add to that array or something.
Yeah. Okay. Let's. I'll start with this, and then let's.
Yeah.
You guide me, and you could be like, "Well, I'll try this or something." Let's call this my array. So this is going to have a empty array to start, and it's going to have a function called add to array. And this function is going to add an object to the array. Let's do my random number. Sorry, how do you do a random number in JavaScript? Math.random, okay. Okay, so this is gonna just add an object to the array, and the object just has the one property of a random number. So that's a class. So classes, I always say, are kind of like the blueprints. They don't usually do anything on their own. You need to instantiate them and create new instances from it. So we'll do new object factory. We'll set this to my factory. All right, and then we'll do my factory dot add to array, and not to overcomplicate, but I'll do it 3 times, and then after each time, I'm gonna just log out what the array is. So we'll kind of see what it's doing. All right, I think that's probably good. So let's try running this and see what we get. Okay, so the first one is 1 object, second one is 2 objects, third one is 3, and then 4. So it just keeps adding it inside. So that's, I don't know, one way to go about doing it. But maybe we can change this up. I don't know if you got another idea for something to try.
Yeah, that's really cool. What if I wanted to, so like you have this array in the earlier with like the team Ruby, team JavaScript.
All these guys.
Yeah. What if I wanted to have a function where I could like input the team name and the goals? Like, I don't know, let's say I have like this data set and I wanted to add to that data set. So I wanted to create some sort of constructor function where I could just like input team name, away team name, home goals, away goals, because there was another game that happened.
Yeah, so how about this? How about we make the constructor take in like games? We'll say it takes in my games. All right. So we can start off with some games, and let's change this. Let's call this add game. And this function is going to take in a few properties. So let's have home team name, away team. We probably won't need to do all the properties. Home team, away team, home team goals, away team goals, and
yeah,
final
cool.
set. Yeah. Okay. Cool. So then we'll do my array.push. All right, so now we can do this here, just like that. Cool.
Oh, cool.
Team name. It's annoying. Okay, home team goals. Away team goals. And finals. All right, so now if I call this, well, there's no add to array method. It is add game, but now it takes all these required parameters or expected.
Yeah.
So we can do tr, tj, 3, 8, and then true. And let's do a few of these. Excuse me. Oh, and then let's pass in games as like our constructor. So I won't log everything out, but I could do just the length of the array. And so we'll do like a before and after. All right, so we added 3 games, so this should go up by 3. So let's try that out. All right, so it started with 5, and then we added 3 games, and then they had all the parameters, and then I went up to 8. We can try running and see what the array looks like, but yeah. Looks like it got them all in here. So these are the three new ones that we added at the bottom.
Wow. It was so clear so quickly. Thank you.
Good. Yeah, glad that helped. I think, classes are really cool because they start to like represent like real world objects. I mean, it's no mistake that they call them objects as they're supposed to represent, stuff that we interact with. So, one way like one thing you may have is even a class called game. And so not to get too crazy, but let's get crazy. So instead of having an array of just these, what we call kind of like plain objects, like this is just a generic JavaScript object or plain old JavaScript objects. However, we're going to make something specific. So we're going to actually create our own game. So the constructor is going to take in all of these parameters. So 5 parameters. It's going to assign each of them. So this is just kind of the, let's make this smarter, not harder. So we're just going to set the basic properties on.
Wait, how did you do that? How did you just type all that?
If you hold down Option and Command, if you're on a Mac, it will select multiple lines.
Wow.
If you use, use the arrow keys, and just like delete stuff at once. So makes things a little.
That's awesome.
Yeah. All right, so now we got like a game object. Game object doesn't really do anything, but nope, gotta get these guys. Doesn't really do anything, but it does represent something that's a little more specific for a game. Oh, sorry about the formatting. Hopefully that is clear. It just kind of dropped everything down and separated it, but still the same code. So, so we got our game. So what's cool is instead of just pushing on a generic object, what we can do is actually create a new game where we pass in all these values. So here, just clean this up. So we got new game. And I know that need another parentheses. All right, there we go. So we are just creating a new game, but let's just do this outside. So we got const game is equal to a new game. So we're actually using this class within this, I don't know, let's call it scoreboard class. So scoreboard class has many games. Let's rename that to games, and then we'll just say pushing the game here. Cool. All right, so now add game takes in the raw data, the 5 data points. It creates a new instance of the game class, and it pushes that game instance onto the array of games. So let's use this. All right, so I'm going to actually just pass in an empty array, and then we'll see what happens. So first we'll start with games.length. It should be 0. And then we'll do this. Boom, my factory not defined because we changed the name. So we gotta change these guys. All right, let's try another one. All right, there we go. So we started with 0 games. And then at the end, we ended up with 3 games. So what's different about this is that you see this game prefix? This is saying like, hey, this is not just any old object. This is a game object. So this is where classes get really powerful. Remember all that code we wrote before about figuring out who won, who didn't win, and it was like kind of messy, and you were like, dude, it looks like you just wrote the same thing. So we're gonna like add some more structure to this. So we're going to have a function called, on the game class, because right now game is just data. There is no functionality on the game class. So we're gonna add a function called is winner. And this is going to take in the initials of the team. Let's just take in the name of the team because we just have names here. All right, so we have an isWinner function. So now we can return, well, let's do this. Const isWinner is equal to, what was all that? Let's go back here. What was that code? Okay, so this is basically the block of it. Well, I kind of need all of this. All right, so we're refactoring this or cleaning it up. So it's going to be this. If this dot home team, instead of initials, it's going to be home team name is equal to name, and it's going to be this dot home team goals, this dot away team goals, and if it is a win, return true. And otherwise, we'll return true. This. All right. So we've basically encapsulated all that messy functionality into a method called isWinner. And so this should return true or false. And this will just return false at the end if neither of these conditions is true. It should return true or false for any of these. So let's just mess around here. Okay, so we're going to add the games. We're going to console.log the games. But we're also just going to iterate through each of the games. And we'll just use a for each loop for now, just to kind of demonstrate. But we'll do console.log. This is where it's really cool, is we can do game.isWinner, and then we'll pass in the name of the team. I guess, okay, that's fine. We're using initials. So I don't know what this is going to produce. Clearly, they won in one time. So I guess we should get one true. But let's see what we get. Oh, we got an error. That's totally not surprising. That was a lot of code to write. Okay, a couple more game instances we just need to change. All right, so false, false, true. So false, 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 true. That makes sense. That's the only one they won. But now we got this function here that's like encapsulated in the class. So it's like tucked away, and like you can pass the game object around and use it wherever. And it's always there. It's represented on the actual like blueprints of what the game is. So what's probably better is saying, let's do a who won function. So this is going to return home or away, just strings to represent if the home team won or the away team won. So we can say if this dot home team goals is greater than this dot away team goals, return home. If this dot away team goals is greater than this dot home team goals, then return away. So now we got another function. So let's just add in another function call here, who won. So we'll print this out. All right, so away one, then home one. So now we're like slowly like building out like what a game means. A game is not just seriously dumb data. This is all this is. It's just dumb data. Now a game is dumb data plus some logic, some functionality behind it. And so it's a lot cleaner, you know, to say game who won, game is winner, versus if you go back here, it's get wins and it's kind of random functions everywhere. So classes provide structure. It organizes code, it makes it cohesive, it groups things together. And as you can see, everything about a game is grouped in a game class. I mean, literally, I can collapse this and there we go. It's pretty organized. Not always so straightforward, but it does help a lot.
That's really cool. Thanks for showing that.
Yeah, absolutely. And then scoreboard, you know, of course you can add more functionality here and so forth, but this is where it starts to get powerful, is now you have the blueprints for something that's like really representative of something in the real world, and you can use this as such. And so if you imagine if you're like working on a big team and you're building a lot of crazy functionality, you can, you know, build, basically works at different layers of the application. You know, you can have someone that's like, okay, hey, I'm gonna work on the game class. That's gonna expose all these methods that you're gonna need for ultimately the HTML and CSS. Don't worry about the logic, I'll figure all that out. Here are the methods that I'm gonna give you, but I'm gonna kind of fill in the gaps. So one way to do that is called stubbing. So you can actually like stub out like the functions of what the class. So let's say you're like, okay, we'll do is winner of the name. We'll do home, who won. We'll do did home win. We'll do did away win. Do is finals, you know, and I don't know. There's only so many things you can do with this, but so you can stub out these methods and be like, okay, you can expect these to work. I'm going to fill in the gaps. I'm going to write the logic, but you can use it. And then that's how we can kind of meet in the middle. So I know, I think you guys have, no, you probably don't have anything tonight, right? I know we were going until 6. I just want to, I realize it's already 5:54, so figure I can answer any questions. I mean, I'm happy to stay on as long as I can help, but I'm gonna answer anything I can if there's anything pressing. I don't know. What else? Anything else I can show real quick? I can even do another example. I can do something in 5 minutes.
Yeah, I was afraid to take up more time because your time is just like so valuable. This is really cool.
No, it's fine. I love doing this, so you are okay.
Could you go over like when to use prototype, like the dot prototype feature? Because I mean, it seems like you can just use. Yeah, never mind.
Do dot prototype or prototypes?
Yeah.
All right, let's save this. Let's call this prototypes. All right. Okay, so the thing about prototypes is they're very similar to classes. In fact, classes didn't used to exist in JavaScript. Classes exist in a lot of different programming languages. Basically all what they call object-oriented programming languages have classes. So if you've heard of Ruby or Java or C#, C++, I mean, countless programming languages have classes. Pretty standard stuff from, I think like the 80s is when like object-oriented programming was introduced. Turns out, 60s. Gosh, that's crazy. Yeah, so literally classes have been around since the 60s. Smalltalk or what are some languages? Anyway, so that's the background. So what's interesting is JavaScript, when it came out in 1995, did not have classes. This guy, Brendan Eich, was like, I'm too good for classes. I don't want classes in JavaScript. Just kidding. I have no idea why he decided he didn't want classes. I think it was because he wrote JavaScript in basically a weekend and recognizes like, yeah, like it wasn't supposed to take off like this. It was a small project, but here we are. Dead serious. That's actually the real reason. So anyways,
what programming language do you use primarily?
So I use a lot of JavaScript. I use a lot of Ruby. Those are probably 80% of what I do. So yeah, I don't have anything against JavaScript, but I do think it's funny that it's certainly not a very I'll say well-designed language. And literally, like, if you like kind of read through the history of like how JavaScript came to be, basically, Netscape, founded by, these early internet entrepreneurs in the 90s, they needed some programming language in their browser. Like, imagine a browser that didn't have JavaScript. It didn't have anything. Like, web pages were just like text and images. And so they're like, we need a programming language. We need to be able to run code in a browser. So this guy is like, well, I could probably write something. I'll call it JavaScript. So he writes something in a weekend, shows it to his boss on Monday. He's like, hey, I think this can work. Like, look at everything we can do in Netscape. And they're like, cool, let's ship it. And he's like, well, I don't know. No one's really seen this. It's just kind of a weekend project. I don't even know if it works out well. And there's a lot of stuff I want to change. Nope, we're shipping it. It's going to go live at noon. Everyone's going to get the update. And so then, fast forward 20 years and we're just now getting real classes. We have double and triple equals. And I'm sure this guy is like, oh my gosh, what have I done? Because that's how it is, but that was so early, like no one could have foreseen what JavaScript was ultimately going to become. And it's crazy to think that, it truly was just a couple entrepreneurs, Mark Andreessen and some other people that were running Netscape at the time, that basically truly pioneered the way to what web browsers are today, with JavaScript. So it's pretty cool. This one guy had such an influential part of the internet. I mean, we could have easily had Ruby on a web browser or C++, but they decided they wanted to write their own, call it JavaScript. So anyways, prototypes.
Interesting. Yeah, that's really interesting.
Yeah, I think it's interesting. But yeah, so when JavaScript was released, it didn't have classes. It had something similar called prototypes. And prototype is like a different way of defining the blueprint of an object. I don't know, I'd have to research the exact nuances and differences of classes and prototypes. But certainly the syntax is very different. And unique too. I don't know of any other language that uses prototypes. It might be a JavaScript thing, although I wouldn't be surprised if there was another language I wasn't aware of that had a similar approach. But ultimately, they solve the same problem. So classes and prototypes solve the same problem. So they're both tools to solve the problem of needing to really encapsulate the blueprints and the functionality that should apply to all the different instances. So I think someone was asking about a sum function earlier. And so there is no sum function in JavaScript on an array. So if we have const array is equal to, let's do my array, 2, 4, 6, 9, whatever. There's no myArray.sum. It doesn't exist. In Ruby and other languages there are, but it's just not there in JavaScript. So you have to use reduce, which requires this sum and current value, and then you got to do current value plus sum. So there's a lot of code to write just to sum things up. Let's say that we're like, you know what? I want a sum function on an array. What's great is we can actually change the prototype of an array to add a sum function. So we're actually going to change JavaScript right now to add a sum function. So we can do array.prototype.sum. So what this is the array is the type. This is like kind of like a class, but it's not a class. It's basically the definition. And so we're going to call the prototype, and we're going to define a new function called sum. So we're assigning array.prototype sum to our new function. And inside our function, we're going to do our reduce. So we got that. And I think this is right, but we'll see if it gives us an error. It's not right. See if this works. So we defined a new function called sum on the array prototype, and all that does is, oh, let's pass in an array. So that's just a normal variable. We'll do that. Okay. It does reduce, does a sum. So, you know, there's a couple lines of code. It's not obvious. But now we can do myArray.sum. And so we'll see if this works. It did not work. It did not work because we did not pass in the array. So let's pass in the array. Oh, wait, no, that didn't work because we don't need to pass in the array. We need to do this dot reduce, I think. I'm gonna have to Google this if this doesn't work.
So when you're saying array.prototype, you're saying like all arrays? Like this is like the array keyword in JavaScript?
Exactly. It's the array keyword. It's extending the blueprints or the prototype of, well, any array.
That's really cool.
One of these days I'll get it right. Let's try that. Let's add return. Wow, I can't even type. All right, 18.
Wow.
6 times a try. Cool. So we just added a sum function on our array. And so literally anywhere in this, well, this file, any array we define has a sum function. So we can do like 2, 6, 7, 5, do dot sum. It's gonna work. So any array has a sum right now. That one's 19. So pretty cool.
So cool.
Yeah, it's nice because if you're like, you know what, I'm, you know, just not a huge fan of how JavaScript didn't have a sum method, but I'm gonna change that for my application. You can do that.
Could you do that with the object keyword too? I mean, no, you wouldn't have a sum thing, but.
Yeah, what would we do on object? I don't know.
You would like, maybe you would check if it's JSON format or something?
Yeah.
If everything is strings? Anyways, I feel like I'm keeping your time.
No, that's fine. As long as you want to. Don't, if you gotta run, that's fine too. But yeah, like I mean, all values are strings, you know, and then it's
oh, cool.
Yeah.
Would you do reduce for this?
Yeah, you could do reduce. Reduce would be good. So we do reduce.
And
we don't. Let's actually do this. So I think it's I think there's an object dot values.
Oh, cool.
So we can do object dot values dot this, and that
the values, object dot values.
Yep.
Oh, cool.
And then all strings and value, and then we'll do return all strings and value dot is string, I don't know if that's a thing. Type of. And then we'll initialize to true. So there's a little bit of logic here, but
oh, I don't know if I get that.
All right, so what this is doing is it gets all the values in an array, calls reduce on that array. This is just like a Boolean flag to say, hey, are they all strings or not? It starts at true, but it's going to change if there's any that are not a string. So then it starts with the value. So we're saying if the value, the type of the value is a string, then we'll return the previous value, all strings, and this.
Yeah, I get it.
And so, yeah, it's so if they're both true, then it's going to be true. But if any of these are false, then it's just going to be false for the rest of it. So,
how did you how long do you think it took you to be able to make logic like this so quick? Like, you know, to generate this Boolean logic. That's really cool.
You know, I mean, it does take time. You know, it does take time, but it just comes with practice. You know, you start to kind of see it enough, and but yeah, it takes time. You know, but you'll grow into it, I guess, or get used to it and develop that intuition.
Can I ask like a kind of a professional question?
Yeah, of course.
Like, where do you see like Ruby and JavaScript and maybe even other programming languages being used, like in, like, you know, I'm sort of exploring because I'm like curious and like kind of enjoying the puzzling of it all, but I actually like have no context of like what kind of job I'll be looking for.
Yeah.
It's kind of a big question, but like would I just be building websites for people? Am I sifting through JSON data? Am I like, do you know what I mean?
Yeah. No, that's a really good question. So generally, like,
or what do you do for a living? Or
yeah, I do a lot of different things. So I do a lot of development, but I do a lot of different like forms of technical consulting. But when I'm doing development, I would consider most of what I do full stack. And so I'll do back end, I'll do front end, you know, whatever. I would say ultimately, like, there's probably a few different paths you'll end up looking at some point. One of them is like to go like the back end developer route. It's less visual. It's a lot of logic and you know, basically like I'm going to write something that someone else is going to use to eventually put something on the screen for someone. So that's like the back end stuff. Or you could go the front end route, which is like, hey, I'm going to actually create the UI. I'm going to use HTML, CSS, and then I'm going to use a lot of JavaScript to define the user interactions and interact with those back end stuff. Or you could go full stack and be like, well, I kind of want to be in a position to cover everything and be able to kind of bounce around and do whatever. I don't know if you ever need to like really make a decision per se. It's interesting because I mean, I get that question a lot. Like, should I go back end? Should I go front end? Or like, what language should I learn? And it's more like, if you think of it more like just tools, you know, it's like when you're, you know, I don't know if you've ever done any woodworking, but usually you would like be like, should I make a table? Versus should I learn how to use a hammer or learn how to use a drill? It's like, well, that's kind of secondary. Like, first figure out what you want to do, and then you'll learn what you need to have to make that. So I like to think of it kind of in the other way, which is like, don't worry so much about what language or front end or back end or whatever. Think more of like, what do you want to accomplish with that? So if you want to build an app, you want to build an iPhone app, then that's going to require that you learn either Objective-C or Swift, totally different. So usually that, I think, is a better way of guiding you versus like what language. But certain languages definitely have an affinity towards certain products or applications.
Yeah. How did you find your way here? Like, do you know what I mean? Like,
yeah,
our career path.
So I started as a graphic designer in high school, and so I had like a little graphic design business, and it was like really simple stuff. Like I was designing logos and business cards and flyers and stuff. So I didn't know anything about programming. I was just doing graphic design, and then I was I don't know, learning more and got really interested in web. And then I was like, I want to build a website. And that was like really daunting, no JavaScript, just HTML and CSS. And so I I remember I had an internship that was really boring one summer. And so I just read a book about HTML and CSS. And I tried to do stuff just to try to keep myself busy. And it was amazing. I don't know. It's amazing, like how much, honestly, looking back, how bad that book was. Many bad things in it, but like, I don't know. It just keeps building, and then I started a startup after college, and at that point I was doing some website development, but I wasn't very good, and I would not consider myself a developer. I was not that good at all, but I was like, I know I want to build the startup, and so I hired a team to do it. And I was paying them a lot of money, and I was like, this is not very efficient. So I was like, I should probably learn this. And so then I kind of taught myself, and I don't know, that's kind of how I got pretty deep into it. So
yeah, wow. Sorry, I got a little interrupted.
Oh no, you're good. No
just
worries.
like the coolest thing, like, I don't know. It seems, it seems like so many careers you have to go through a whole sort of stratified system. It's like this many years of school and this many years of internship or shadowing somebody. But it's just like it seems like just the world of tech. It's like you have a great portfolio and you get a job. Oh.
Yeah. It's pretty unique. It's probably one of the only industries where you don't really need like a lot of credentials, and sometimes oftentimes it's ignored. I mean, I've been in positions where I've hired a lot of people over the years, and I never look at school or anything like that. It's really like show me your experience. I mean, if someone's just coming out of school, I'd want to see like school projects and stuff like that. But it's very meritocratic, I guess. It's based on what you can do versus where you went to school. So
hey, well, thank you both so much. Like, thanks Natalie for like bringing Sean here, and Sean, thanks for your time. This was like, in just a short period of time, I really like all of the things that have sort of been floating around in my mind, I think found land.
So. Oh, good to hear. Well, hopefully we can do another one sometime. Maybe the next one you guys will be so advanced, I'll be struggling to keep up, but